Each time you fold a piece of paper in half, it doubles in thickness. If a piece of paper is 0.05 millimeter thick, then you can determine the thickness y of a piece of paper given the number of folds x with the function y equals 0.05 times 2 to the x power. Identify the key features of the function, graph it, and then identify the relevant domain and range in the context of the situation. So the first thing we want to do is identify the key features. We're going to look first at the domain and range, then the y-intercept, and then the end behavior. Because a is greater than 0 and b is greater than 1, y equals 0.05 times 2 to the x power is an exponential growth function. So the domain is all real numbers and the range is y greater than 0. The y-intercept is the value of y when x equals 0. So if we put in 0 for x, anything to the 0 power is just 1. So 2 to the 0 power is 1, and 1 times 0.05 is 0.05. So the y-intercept is 0.05, which makes sense if you think about it in the terms of what you're actually doing. Your piece of paper is 0.05 millimeters thick, and if you haven't done any folds to it, 0, that's where you're at. The end behavior, because it's an exponential growth function, as x increases, y increases, and as x decreases, y approaches 0. So we have our domain, those are our x's, which is all real numbers, everything going up 0 through infinity, okay? And we have our y's, which is our range, which is everything bigger than 0. So we're going to be looking at our graph going up. So we make a table of our values, use some negative numbers so you can see all of the graph. And we put in our numbers for x. We already did when x is 0. That's our y-intercept. And then we put in some positives, and we can see a nice curve happening here. And as you get more and more folds, notice it gets exponentially more thicker. I don't think that's the correct English way to say that, but you guys understand what I'm saying. The relevant domain and range, we're not really going to want to look at the negative stuff, so we're only going to be looking at the positive numbers because the number of folds cannot be negative, right? You're not going to do a negative number of folds. I folded this paper negative 17 times. No, that's not going to happen. So we're only going to be looking at the set of whole numbers that are positive, right? We're also not going to fold it like half a time. However, because paper cannot be folded indefinitely, the thickness of the paper cannot continue to grow to infinity. So the domain is restricted to the greatest number of folds, and the range will be restricted to the greatest thickness of the paper. Right? So realistically, we're not looking at 0 to infinity on both the x and the y because eventually you're not going to be able to fold your paper anymore. How can you determine the y-intercept without substituting it? Let me just try that whole sentence again. How can you determine the y-intercept without substituting into the original equation? Hint, consider that x equals 0 and the y-intercept means in the context of the situation. I gave you that answer in the video earlier, so if you want to go back and think about that, copy down some stuff maybe that I said, write down your own thoughts however you want to do it, but have an answer ready to go because you will see this later on our Canvas page. Making an organized list of x values and corresponding y values is helpful in graphing the function. It can also help you identify patterns in the data. When you're doing exponential graphs, tables help. And here's a video of graphing exponential functions on a graphing calculator. Remember that on the common resources part of our Canvas page, there is an online graphing calculator that you can use. It'll be very similar to this. So let's take a look at this video.
You can graph exponential functions on a enter the function in the round equals list and graph the function in the standard viewing window. To find the y-intercept, press second and then trace to access the top menu. Select the value feature. Enter 0 for x and press enter. The value of the y-intercept is shown at the bottom. You can visually